Good morning to all. Today we are going to talk about the first unit of the engineering chemistry, water technology, and why we have taken this water technology as the first topic is we know very well the water is very important for the nation, and people are saying that next world war is going to happen because of the water sharing. And according to the engineering point of view, we are going to talk about the water technology and what are the problems we are facing because of the water and how this problem is creating a very big issue in the industrial area. So that is the objective of this topic. And we are going to talk about the next topic over here. What are the topic contents we are going to see is hardness of water, disadvantages of the hard water, estimation of the hardness, softening methods, that is how we can solve the issues of the hardness, and desalination technique. We know very well that 3/4 of the world was covered by the water, and only pure water is very less percent, and we are getting from the underground. And the sources of water we know very well: rainwater, river water, lake water, and sea water. So the purest form of the water is the rainwater, and that rainwater we are saving in river and lake, and we can use it for the various purposes. And another one is the underground water, that is the spring water, or it is present in the well water. And when we talk about, before going for this hardness and the topic of this water, we have to know what are the physical impurities and chemical impurities, biological impurities which is present in the water, and how it is affecting the quality of the water. So based on this we can solve the issues. And if you talk about the physical impurities, we know about very well that water is colorless, and it is tasteless, odorless, and it is just H2O, it's a pH is neutral. And because of the dissolved salts, there will be change in the color, there will be change in the taste, odor, conductivity, etc. Same way, if the chemical impurities are present, like inorganic and organic chemical impurities, so they may also affect the minerals content, pH, alkalinity, hardness of the water. As far as this biological impurities is concerned, we are going to talk about the microorganisms and water bodies. So that is the zooplankton, phytoplankton, bacteria that is contaminating the water. And now we enter into the topic of the hard water. This is more concern about the industries, because we know very well when we take the water, just you can see the white precipitate is settling down, and especially when you are boiling the water, you can see this and observe this white precipitate will be forming as a scales. And what is the reason for that white precipitate is? So here we have two different types of the salts which is present in the water, calcium and magnesium. And this calcium and magnesium is major problem which is creating in the hardness, especially in the case of the industries. And when we talk about the hard water, that is the major problem is the calcium and magnesium salt. So if the calcium and magnesium salt is present in the water, so that is called as the hard water. And the softness, like if you take the water, it should contain the soft, that is the sodium and potassium should be present up to 17. Hard water, normally what we are drinking should be in the range of 60 to 120, and it's above 120 is a hard water, we can say. Very hard water is above 180. And nowadays if you check the hardness of our household waters, that may be around 1900, like that. And why we are more concerned about the hard water? So here you can see this. So the hard water which is resulting the scales, and it is creating a problem inside the boiler, like the pipes or the clogs. And the hard water is the precipitate, how much precipitate it is forming with the soap. When you are washing your clothes, you can observe that water will be creating a problem with the precipitate. And this hard water, it's because of the, and not only it's forming the precipitate with the soap, and also it will be clogs the pipes, boilers, and as a lime scale. And as in the chemical point of view, we'll be talking about the hard water, because just we can say if your sample is containing the calcium and magnesium, it's creating a hardness. And in the chemical point of view or chemistry point of view, how we can say about the hardness is, just you take a soap and that is nothing but the sodium stearate or the calcium stearate, and that is sodium stearate that is treated with the calcium chloride, that is nothing but the hard water, and it will be forming the lathering with the soap, that is it forms a precipitate. So calcium stearate will be formed as a precipitate, or the magnesium stearate will be formed as a precipitate, so that is called as the hard water. So general people, to common people, how you can say is just take a water and mix it with the soap. If you are getting a precipitate, we can say the hardness is more in your water sample, and chemical person will be saying the reason for that hard water is calcium and magnesium maximum is present. So if your sample is having calcium and magnesium, we can say that is a hard water. And here we have two different types of the hard water. One we can say about the temporary hard water, and another one is the permanent hard water. So what is the difference between the temporary and permanent? So temporary, we know very well, it's called as the carbonate hard water. Permanent is non-carbonate hardness. Temporary, it's a temporary one, so we can find out the solution for the temporary. So how we can find out the solution for the temporary hardness? And this temporary hardness is caused by the presence of the dissolved bicarbonate, calcium, magnesium, and other heavy metal ions which is present in the hard water. It is mostly destroyed by more boiling of the water. So when you are boiling, it will be forming a precipitate. So the carbonates, calcium bicarbonate and magnesium bicarbonate is present in your water sample, means you can make that as a precipitate in the form of the calcium carbonate or in the form of the magnesium hydroxide. So that is called as the temporary hardness. So just boil the water, filter it, you can remove the precipitate. So that is nothing but the precipitate which is responsible for the temporary hardness. And permanent hardness, really it's a permanent problem for us, and that is because of the non-carbonate hardness. So like a calcium and magnesium ions which is reacting with the heavy metals, then it will be creating a permanent hardness. And what is the solution for this? If it is a temporary, you said that we can boil it and we can remove the hardness. And in the case of the permanent, what's the problem? How we can face it? So here also we have some, if there is a problem, some solutions will be there to solve out the problem. So we have the solutions, so that solutions we can see little later, after we can see how this hard water is creating a problem in the industries. Not only in the industries, even in the domestic usage also it's creating a problem. Like when you are washing the cloth, so as we said, it's creating a precipitate. So not only the precipitate, even if you see the cloths after you washing with the prolonging washing with the hard water for a number of days or number of years, the color of the cloths will be turned, and what we can say, the holes will be happens, and bathing, you cannot take your bath properly, drinking water will be bad quality of the drinking water, and it's creating a problem, and you cannot use that much hot water for the cooking. And so these are the problems which we are facing in the domestic usages. And in the case of the industrial usage, so irrespective of all the industries which is facing a problem with that, like a textile industry, sugar industry, dyeing industry, paper industry, and pharmaceutical industry, especially in the case of the steam generation in the boilers. And mainly we are going to focus the problem of the hard water which is created in the boilers, like it's creating a problem in the scales and sludges, priming and foaming, and boiler corrosion, caustic embrittlement. So one by one we can see. First we'll be talking about the scales and sludges. So what is a sludge? So when we are taking a water and when we are boiling it, so it's creating a problem of the loose and very slim precipitate. So that is called as the sludge, and this sludge is it will be creating a problem. So this can be removed for a smaller period of time. So like when we are scraping with the brush, and we can remove the precipitate, and that can be solved. So this will be collected especially in the boiler area, and when it is in the hot condition, so the hot water is creating a salts like magnesium carbonate, magnesium chloride, calcium chloride, magnesium sulfate, etc. So this salts which is responsible for the formation of the sludges. And if the sludge is forming in the boiler, So what type of the problems we'll be facing is, so the water which is present in the boiler will be having the poor heat conductor, and along with the scale, it's absorbing into the scale before more hardened, and excess sludge formation also will be takes place in the boiler, and that is creating a problem in choking of the pipes. So how we can prevent this sludge formation in the boiler is, you can use the softened water, and you can remove the sludges by the blow down operation method. And in the case of the scale, if you're prolonging heating, and it will be forming a very big precipitate, so that is creating a hard adherent coating on the inner walls of the boiler. So this thick precipitate which has happened in the boiler side, this is the water, and this black color is nothing but the precipitate. So after you are heating in the boiler, so it will be forming as a thick precipitate, hard precipitate. So that is very difficult to remove. Even you have to take the hammer or the chisel. So that is creating a problem in the hard water. And the reasons for the formation of the scale. So why the scale is happening? If you see in the low pressure boilers, we said that calcium bicarbonate is responsible for the temporary hardness. And when you're taking this calcium bicarbonate, it's when you are heating in the low pressure boilers, so at high temperature or the pressure, it's creating a problem of the calcium carbonate, that is a scale. Whereas in the low pressure boiler, the same calcium carbonate that is converted into calcium hydroxide, so that is soluble, so along with the water it will be goes off, and it will be not creating a problem in the boiler. So the calcium bicarbonate in the high pressure boilers, it's creating a problem, whereas in the case of the low pressure boilers, it won't be a problem. And in the case of the calcium sulfate also, in the high pressure boilers, that is in the high temperature, it is insoluble. In low temperature, it is soluble. So when you are in the boiler, will be heating the boiler in the high temperature only. So it's creating a problem that salt will be formed as a precipitate at the high temperature. So that is creating a problem here. And in the case of magnesium chloride, that is also creating a problem in the high temperature boiler by forming the scale magnesium hydroxide. And then we can talk about the silica, that is it forms the insoluble hardened calcium silicate and magnesium silicate. So that is the important source in the scale formation. So let it be the scale let form. Why we have to bother about that is, see, when we are using in the boiler, you have to heat it for a long time because you have to make your water to boil. But if you see that adherent coat has happened in the sides of the boiler, so it will be taking maximum time for boiling, and maximum temperature you have to give it for the boiling, and it's creating a problem in the risk, and it reduces the efficiency of the boiler. Sometimes if you have the crack inside the boiler because of the scale, it results the explosion. That is also creating a very big problem. Okay, we have this problem. So how we can remove the scalers? So as we have seen, we can go with the hardened brush and hammer and chisel, and we can do that. But the problem which we can go with solving is 5 to 10% of the HCl. We can add it with the DDT ADA, and we can remove it. And apart from that, in the industries, small type of the problems we cannot. With small type of the problems we can, but if it is a high big problems like creating the hardness, so how we can treat the hot water before it's going to use for the industrial applications. So what we have to do is, we have two different methods in the prevention of the scale formation, like internal conditioning or internal treatment, external conditioning or external treatment. So just we'll see only the internal condition today, and remaining we can see in the next class. Like internal conditioning, so before you are going, the water is inside the boiler, and you are going to add some conditioning agent. So we have three different type of the conditioning agents: phosphate conditioning, carbonate conditioning, and calcine conditioning. So what we can do is, just you add a phosphate substance in the water, and that is reacting with your calcium chloride, and it is creating a precipitate. Calcium phosphate will be formed as a precipitate. So this will happens in the high pressure boilers. So the phosphate sample can be removed by means of this method. So one is by adding the phosphate, And another one, we can add the carbonates conditioning. Suppose if your carbonate is there, by means of adding that carbonate we can do it. In the phosphate conditioning, you have three different type of the phosphate substance. You can add it in the boiler based on the pH of your water. So if your calcium cannot be precipitated below pH 9.5, then you have, because you have to maintain the pH of 9.5 to 10.5. So based on your water pH level, you can select your sodium phosphate or the disodium hydrogen phosphate or trisodium phosphate. So based on the pH which is present in the water, you can select. And remember that the calcium should precipitate only the pH range of 9.5 to 10.5. And whereas in the case of the carbonate conditioning, you can take the sodium carbonate and the calcium sulfate. It's a hard scale forming thing, and the calcium sulfate, when it is treated with the sodium carbonate, it's creating a calcium carbonate. So that is loose precipitate and it's a sludge and it is forming a precipitate, and we can remove it. And in the case of the Calgon conditioning, so we can add the Calgon, that is a substance, it's called as the sodium hexametaphosphate. So that is added with the water, and that's just creating a soluble complex. So that precipitate can be removed easily, and this is one method we can remove it. And apart from that, if you see in your after you added all these things, you will be having some fine particles will be there in the water. You can add some coagulant, and after adding the coagulant, it's like a magnet, so just it will be trapping all your precipitates, and it's forming as the aluminum hydroxide. And this aluminum hydroxide is a precipitate, it will be settling down and you can remove it. And even in the case of the oil drops or the silica also, you can remove it by this method. So these are the various techniques we have in the case of removing the internal treatment method. So remaining we can see in the next class.